What is quantum computing? Well, before explaining that, you first need to understand how a classical computer works. Most computers, like your rinky-dinky old laptop, are classical computers. They use bits that act like tiny switches. When the switch is off, it's represented as a 0 in the computer, and when it's on, it's represented as a 1. Everything in a classical computer is calculated using these bits, which poses some problems in bigger calculations. For instance, if you wanted to consider 3.6 million ways 10 people could be seated at a table, for whatever reason, the classical computer would need to run through all of the 3.6 million ways, one at a time. That's why simulating individual molecules still requires supercomputers that take up entire warehouses.
So what are quantum computers? Quantum computers are computers that use concepts from quantum mechanics to perform multiple calculations at the same time. Unlike basic computers, quantum computers are big, quirky, and use qubits, which are usually subatomic particles like electrons or photons, instead of standard bits.
Superposition is a concept of quantum mechanics in which a quantum object has the ability to be in multiple states at once until it's measured. In terms of qubits, the qubits are on a spectrum of being on and off at the same time. Entanglement is another one of the cool and quirky concepts utilized by quantum computers, where the quantum states of multiple objects, or in this case qubits, must be described in reference to each other, even if the individual objects are separated. This is otherwise known as spooky action at a distance, from Mr. Einstein. An easier way to think of this is like flipping two coins. Normally, the result of one coin wouldn't influence the other. However, with two entangled coins, if one coin flipped on its head, then the other would too. Qubits use entanglement to link and move around information, even if it contains uncertainty, and helps the computer perform complex calculations.
Using these concepts, quantum computers are expected to have huge impacts on simulations, cybersecurity, drug development and discovery, AI, electronic material discovery, and weather forecasting.
Quantum computing engineers, in short, deal with the quantum mechanics, electrical, and electronic engineering systems, engineering, and computer science of quantum computers. There are a lot of factors that quantum computer engineers need to worry about because quantum computers are extremely sensitive to environmental disturbances, such as supercooling the computer or keeping the computer in a controlled environment. These engineers also need to worry about controlling the qubit to perform logical functions, usually through a finely tuned pulse of electromagnetic radiation. However, as mentioned before, quantum computers are extremely sensitive, so engineers have to balance between protecting the qubits from disturbances and manipulating them for calculations.
Quantum computing engineering requires certain educational degrees in order to realize the complexity of the occupation and its specialty. The average quantum engineer must earn at least a bachelor's degree in computer science or engineering, although a master's or PhD is preferable. In general, advanced degrees in quantum physics, physics theory, math, engineering, or computer science are a good start. A focus on machine learning or artificial intelligence will also be ideal for a dynamic quantum skill set. Understanding quantum computing means also understanding the prerequisite levels of math and physics. Important topics used in quantum computing include basic quantum mechanics, linear algebra, basic group theory, basic probability and stochastic processes, Fourier transforms, basic algorithms, and analysis of algorithms.
As of March of 2022, the salary for a quantum computing engineer in the United States ranged from $73,745 to $160,355 per year, with an average pay of $108,744 annually.
There are quantum processors located around the world, but most of them are small scale and have 20 qubits or less. IBM, the International Business Machines Corporation, is one of the leading producers of quantum computers. IBM's Eagle is a quantum computer with 127 qubits, located in Yorktown Heights, New York. Google is another competitor in the quantum race. Their Bristlecone has 72 qubits and is located in Mountain Heights, California. Additionally, the University of Science and Technology of China has a quantum computer called Zhouzhang with 76 qubits located in Hefei, Anhui.
Finding a job would likely be easiest at either Google or IBM due to their locations around the world. For example, IBM has quantum processors in Tokyo, Texas, London, Dublin, Manhattan, Montreal, Mumbai, Paris, and many more.
This range of locations prove that there are quantum computers among us.